I started. I would expect the guys to be in, but no. So 18 is all we got left. You guys are gonna forgive me if I'm a little slow today. I'm not feeling my best. So I started a little late because I was throwing up. So hopefully that's under control and stopped now. But yeah, I think I just ate something bad. It's nothing like I don't have a flu or anything like that. I don't feel like a cold. It's just literally stomach bug. So I'm guessing I just ate something bad or whatever, or, you know, not eating the right stuff, whatever it might be. So I'm hoping that I can get through this lecture and everything without interruption or minimal interruption from having to make an emergency break or stop or pause. I do not want to do that. I want to just go through. So, excuse me. Ooh. Okay. Now, chapter 18 goes over troubleshooting modern refrigeration and HVAC equipment. The whole thing with modern HVAC is this idea that we are going to use a very we use very controlled, or we use various controls in an electric circuit. You usually put it in series with a component to sorry. Okay. So we'll use controls usually in series with a switch or a coil or some sort of load. And the reason why we do these switches in series with our loads is to make it so that the whole time that the system's operating, we know that the switches are operating as well. They're letting power pass through. And we can have it be manual switches, like for a gas furnace. You'll typically have a couple of manual switches. One will be a door switch that'll open if you take the cover off to access the system. and it'll shut power down going to the system. That's a good safety to have for people who aren't professionals and decide I'm going to go start working on my HVAC unit today. So the other one you're going to see for gas furnaces as far as manual switches is we'll have a manual switch for the entire gas furnace on the outside of it. That'll be an emergency shutoff. But that's external to it. That's something we put in that the manufacturer doesn't. What we're going to see the manufacturer put in a gas furnace, it's a manual switch, will be that door switch, and there's a switch on a gas valve. So the switch on the gas valve has got it where it's got to be in the on position before it can try to do anything. If it's going to be operating, so the electrical components are going to be fired off in series with their controls, with their switches, in order to make sure that they come on. Some things are going to be simple. Like I said, for a gas furnace, you'll have a couple manual switches, which will be easy enough to turn on and off. You flip a switch or you push it down or something like that. What's going on, Chris? So I'm going to do my best to get through this. I'm not feeling 100% today. I think I ate something weird. My stomach's been acting up, so I'm trying to just get through this as quick as I can right now. All we've got for today is just chapter 18, and then we're going to do
Sure, I guess it's just me and you, huh?
Yeah, I think so, yeah. I guess everyone else is like, oh, it's Monday the last week, you know. I'm currently trying to also put your final onto Canvas. I just gotta, it's just copy and pasting 50 questions and answers, which is very time consuming. So I'm trying to get that done. Excuse me. But this is just going over troubleshooting controls on all sorts of systems we've got. They're going to be, depending on how modern it is, how old it is, how large of their equipment, how small our equipment is. That's going to be your factor for a lot of the controls as far as the complexity of it. Also price, you know, it's the more expensive units are going to have more and more controls. Newer units are going to have more and more controls because it's just like cars. The newer models have more and more stuff with them. You know, it used to be you get an old muscle car or a Volkswagen or something like that. All you got to understand is basic DC electricity and how an engine works. That's it. But modern cars, because they've got more safeties, more controls, more features to them, they have literally a computer as part of the engine. And we're getting to that point in HVAC as well, where it used to be very mechanical, basic electrical. You had, you know, it was just a contactor, a couple switches, done. Now we're constantly having the system read and send information back to our control board, to our control systems, in order to have that system operating precisely, you know, and have that great precision and accuracy for changing temperature, whether an increase or decrease. When we're moving heat, we're just trying to get it to be the best as possible. So having electrical systems become more and more complex has been basically a trend in HVAC going on for years now. It's just what happens. You know, it used to be maybe 2 switches in series with a contactor, and now it's 20. Now, and then it's not even going to be 20 physical switches you can test. Most of those switches and relays and components are now becoming part of the board. Even capacitors are becoming part of the board. It's no longer required on some systems to have an independent capacitor that you can replace easily. It's part of the board system. So if it goes bad, if that capacitor goes bad, you have to replace that whole board. And typically that's going to be pretty expensive compared to just a capacitor. So there's drawbacks to this. But the benefit is typically because we have so many more controls and because that capacitor is part of the board, it's integrated, it's part of it from manufacturer. They designed it to be in that system. It's going to last long. It's not going to be your capacitor goes out and, you know, every couple of summers, it's going to be your capacitor never goes out, never needs replacing until that system dies or the board gets fried. That's the only time you're going to really have to get a new capacitor on this. So that's what everything's switching to. It's switching from independent components to, it went from just independent components with like a thermostat to a thermostat, your independent parts like I'm talking about relays and contactors and your motors and everything. And then, you know, it upgraded from there. It went from just a thermostat to a thermostat and a board to a thermostat and 2 boards to now you've got it where it's all communicating. It's all digital. Microprocessors being used for just about everything. But even with that microprocessor, with these more complex boards and everything, you're going to be testing and seeing if that board's operating and working properly. And manufacturers usually include some troubleshooting guides for their control boards. Sometimes some of them will have it where there's an error code system on the control board that will let you know, it's not the control board, it's probably something else. But typically, what we're looking to do with that is, making sure and seeing if that board is actually doing its job. Is it sending voltage? Is it sending capacitance? Is it sending energy out where it needs to go in our system? But getting used to electrical troubleshooting, this is why Saturday I really wanted to focus on, not just wiring things up, but hey, let's test it with a meter and, read what we're going to read when it's open or closed and all that kind of stuff. Because that's basically troubleshooting. That's what you're going to be doing. There we go. Billy's coming in now. So the electronic components that we're going to have that are going to be energized, that are going to be passing power through, that are going to be doing whatever it might be, they are the main thing we're going to be checking and troubleshooting. You will have troubles with refrigeration. I don't doubt it. You're going to have refrigerant problems. You're going to have gas pressure problems. You're going to have water pressure and water source problems and all sorts of things that can occur outside of the electrical field. But day in, day out, majority of your troubleshooting and majority of your time is going to be spent doing electrical problems and electrical troubleshooting. So familiarizing yourself with schematics and what those ladder diagrams and everything like that, that is going to be a really great way to it's going to be a really great way to be able to actually test and look at your controls and everything like that, and look at your components. So it's contactors, it's relays, it's boards, it's motors. All of that is electrical. Every single part is electrical. There's very few parts of an HVAC system that are non-electrical, that are only mechanical. Even our expansion devices in that refrigeration cycle are getting to be electrical now. All right, so motors, like I said, they're going to be your big loads on our system. We really don't have any loads in an HVAC system as far as high voltage is concerned that is not some type of motor, whether it's a compressor or a fan motor or a pump for water. They're just, different flavors of the same thing. They're just motors. So they're going to have the same kind of testing. They're going to have the same things we look at. We're going to look at resistance across our different coils. We're going to try and find our common run and start. All that kind of stuff is what we're going to see for a motor, typically. Switches, however, they're going to be the ones that are a little more often to break, honestly, and they're going to be the one you check more often because those components break so easily. So switches, typically we're going to see it where you've got it where there's a number of them, and it's really just getting used to and getting familiar with the different styles of switches as far as what they mean when you see them on that wiring diagram, So you've always got your basics are going to be there's only 4 positions really a switch is going to be in. That's it. So let's tear up the circle. Okay, let's see. So the 4 positions for a switch are going to be normally opened, close on a fall, normally closed, open on a rise, normally open, close on a rise, normally closed, opens on a fall. So that's really all you're going to see as far as your switches. They're either going to be normal, which means, again, normally, we're talking about when the system is de-energized. So we've got our normally open switches, we got our normally closed switches, and they're either going to be, and this is a manual switch is all this symbol stands for, but you can add a symbol to the bottom of it, and that's going to change it. It could be a switch for pressure, or for temperature, could be a switch for airflow, could be for a float switch that checks for water level, or a you can have it where it's checking for not just water level, but actually the movement and flow of water and everything. So we've got, there's all sorts of ones. You got sail switches and yeah, it's typically sail switches, pressure switches, temperature switches, and floats. Those are going to be your 4 most common. Checking for movement of air, checking for change in pressure, checking for a change in temperature. Those kinds of things are what we're going to look for with our switches. Now, the main thing is just understanding that, if you have an open switch, you're going to read your source voltage, whatever. If it's a 24 volt switch, you're going to read 24 volts. If it's a 240 volt switch, you're going to read 240 volts. It's just whatever that source voltage is, what's coming in that line, that's what you're going to read on an open switch. On a closed switch, you should always read 0 volts, always. That means that it's a closed switch. If you read something other than 0, that switch is open. And by 0, anything less than 1, so 0.22, 0.3, something like that, that's fine. Not ideal, because what's happening is if I'm reading 0.2 or 0.3, and I've got my meter, my leads on there are really nice, they're not, barely making contact, they're actually right on it and everything. That just means basically that I've got a system that If I've got it where I've got my leads on there, I'm reading some level of voltage, but it's less than 1, but it's not 0, it's 0.22, 0.33, like I'm saying. That means that that switch is consuming 0.22 or 0.3 volts from the start to the end. Right there in the middle of that switch, we're consuming electricity. And that could happen because the switch isn't closing properly. I mean, you see how these are lined up? That's literally what it means. It's gonna make contact. It's gonna take 2 pieces of metal and put them together, typically. But if we have it where there's no reading voltage, that means that it's making contact, but it might be a little off angle. It might not be a flat, nice connection. It might be a little off, it might be a little up. We're still connected right here. My hands are connected all this way. So if I'll read, close to it, but it could have just a little bit of a gap, and that can happen because dust, because of bug parts, because of debris or anything really getting in the way of that switch. It's why relays have pretty much always been sealed up, because they're in areas where they usually are going to have a lot of dust and debris. So you don't have to worry about, the switches inside of a relay getting, gunked up. It's also why contactors nowadays have been switching to more and more enclosure, more and more getting basically a case around that thing to protect that contactor and its contacts, so that when it operates like a switch and it closes, have that closure. We're not going to get a loss of voltage because we've got, bug parts built up in between or something like that. So contactors, relays, really what we're going to be looking for these is we're checking our voltage in and our voltage out, our line and our load, and then we are checking our coil, checking those 2 parts of a contactor or a relay to verify they're working properly. If a relay or contactor, and you're checking its voltage, you go out to the outdoor unit and you get to the contactor, there's 3 places you check for voltage. 1, you check and see if you're getting your voltage at the coil. You're going to check for that, verify that it's the correct voltage, the correct amount. If it's low, then it's low, and you need to go start looking and seeing, okay, from my origin of my power to this contactor to this relay, where am I losing my power in that path? Sometimes it's complicated and hard to find, and you might not, it might just be that it's a loose connection. Other times it's going to be pretty simple. It's it's a chewed through wire that you can see the copper right there. The contactors and relays, it's really just, you check that voltage at the coil, make sure that it's getting the proper voltage. If it's energizing, then it should pull in and switch our contactor to an energized mode. You're going to check your mechanical linkage on a contactor. Is easier than a relay. You're going to check your, like I said, line voltage, checking that 120 or 240 coming in. And then on the other side, checking and making sure you've got your 120 or 240 coming out. If a contactor coil is energized and doesn't close, bad contactor. Contactor coil is energized and the line voltage coming in is wrong. Check your line voltage. If you've got proper line voltage, your coil's closing down everything and it's sending power through to the other side, then you might want to start looking at your motors. Or your capacitor. If you've got a basically you've got a loss of voltage across a contactor, that's when you've got, or a relay, you've got it where it's not working. Because the whole idea with the contactor or relay is it's just a switch. It's an automatic switch that we're going to have that's going to pass power through and send it on to the next component. Transformers are simple enough to troubleshoot. You check for the voltage coming into the system, into the transformer, so 120, 208, 240, and then you check your voltage coming out. That's it. Check and see. Is it getting 120? Is it turning into 24? Yes? Good. it's not, then go with a different system, or get a new contactor or something, or not contactor, transformer. So the transformer, what you're looking for is you're looking for the correct amount of voltage and everything like that coming out of it. If it's a little high, let's say we've got a transformer that says, okay, I'm supposed to make 24 volts and instead it makes 28. That's really not too much of an issue for us. Typically low voltage, if it's a little high on the higher end, it's not going to be too terrible for us. But if it produced too low voltage, that's when we're getting into trouble. If I get it where I've got a contact or a transformer that's supposed to produce 24 volts and only produces 20, new transformer right away. So typically you're going to see it where they won't. It's not going to be like they produce voltage or they don't. It's going to be they produce less and less voltage and less controls for the system and everything, because that low voltage powered off the transformer for residential systems is going to be our link, our power source for all of our controls, whether that's our control board, whether that's our thermostat, our coils on our relays and contactors, all that kind of stuff is going to be protected by that. And then overloads, looking at your fuses, making sure your breaker's not tripped, stuff like that. All you need, y'all have a massive tool bag. That thing is a big old duffel bag of tools. It's fantastic. Glad you got all those tools. Because I know when I started in the field, I did not. It sucked. Out of that bag of tools, you really only need a handful of them to do diagnostic work, on most systems and most problems. Because I said, and the thing said at the beginning, 75, 80, 90% of your HVAC problems are electrical. So that means that on the majority of my calls, 80 or 90% of them, I'm not going to have to take my gauges out. I'm not going to have to check refrigerant levels. All I've got to do is get my meter. So let's see if I can find where's that? I'm sorry, I got a text from the dean, so I gotta email her in a minute. But
what the dean talking about, man? She ain't talking about nothing good.
No, she's always just asking for attendance forms and stuff like that I'm turning in all the time. Since we've gone to online, you would not believe the amount of paperwork I have to do now.
Yeah, I bet.
Yeah, it's like 3 times as much as I used to. And I'm just like, oh, great. Not like I was behind it before or anything. So, but what was I saying? The tool bag you got, big, it's bulky. That if you go to work residential, if you go to work commercial, if you're up and down off of roofs, crawl spaces, schematics and stuff like that, you do not want to be carrying around that big old duffel bag, tool bag. Trust me. It's just a pain to do that. You're going to hurt your shoulders after a while, and you're going to be tired of it, and you're going to be like, I don't use half these tools anyways. You can get away with a tool pouch. The one that I use, it's a small little pouch that clips on my side, and I can got in there. I got my meter, I got screwdrivers, I got nut drivers, because that's really all I need. And a couple pliers, I got my needle nose, I've got my wire strippers and cutters, and a couple wire nuts, jumpers, all the stuff I need to do electrical diagnostics. I need my screwdrivers and nut drivers to take the covers off the panels to get into the system. I need electrical tape to tape down door switches, to tape up connections after I put a new wire nut on something. I need wire cutters and strippers because I've got it where I might just have to do a new connection real quick. That's all I need to do. I could have it where I've got needle nose pliers to pull off wires off terminals really easily without having to worry about breaking them or damaging them, because just tugging on them is not always the best thing. You guys have probably done it where you just tug and then all of a sudden the wire comes out and the terminal end stays there. And that's never fun, especially when you're on a call and you're on the clock and you're trying to get things done as quick as possible. So, it's just a handful of tools. That's all I really ever needed to go into someone's house and at least get started. A temperature probe to check and see if the airflow is actually changing temperature or anything like that. And then that's pretty much it. That's all I would really ever need. It just makes your life a lot easier. It makes it so that you can look a little more professional when customer answers the door, or you walk into a place of business. You're not walking in there with this big old tool bag and you're going to set it down on the floor and you're going to take up all this space or scratch something up or whatever. You don't have to worry about that. With that tool pouch, that was one of the nicest things about it was I never worried about, okay, when am I going to put my tools down and where am I going to put them down? Because you're going to be standing in hallways, working on systems. It's just what happens. You've got a thermostat right there. You're going to spend 10 minutes. So you take the cover off and you're taking out your screwdrivers and all that stuff. Well, as opposed to a big bag on the ground, I've got it right next to me on my hip and I'm just pulling it up nice and easy. Getting all my tools, thermostat screwdrivers, 6-in-1, stuff like that. 6-in-1 is honestly one of the best things to have because that includes Phillips and flathead, 1/4 inch and 5/16 nut driver. That's the 4 things that you need to get into a system. So it makes life a lot easier. But yeah, the main thing is, avoid misdiagnosis because it sucks when it happens because you'll replace a part and then, the system still doesn't work. And you're wondering what the heck just happened, what's not. I thought that was the part that was wrong. Sometimes, and this can happen, this is not an excuse. People sometimes will say, oh, you're just making an excuse. It's not. There can be secondary issues. If I go into a house and I see, oh, bad transformer, all right, I replace the transformer. Well, now, first time in a while, it's producing 24 volts. So now I'm going to see, okay, well, how do the controls work? What's going on with my pressure switch, my relay, my contactor? All that kind of stuff is going to start playing a factor to it. So I've got to let a customer know beforehand if there might be a secondary problem. If it's something major like that, like a transformer or some kind of switch or something like that, it could easily be, you got one bad switch, you replace it, and guess what? The next switch is also bad. But you wouldn't have known because you didn't have voltage there to test it. You didn't have any way to look at it while it was being energized. Because it was a normally open switch, so of course it's going to read OL or something like that. But it's just important to make sure that you're really taking your time with this. Don't rush to conclusions. Keep it simple. Always keep it simple. It's usually an electrical problem. It's usually nothing too crazy. It's just let's see what we got going on. So like I said, your meter, your number one tool. Y'all should be every day looking, if you haven't already read through that entire DEI user's manual for your meter, read through it. Read through that whole thing. Know that meter well. Know how to use it, know how it works, know how it operates, how to take care of it, all that kind of stuff. And usually after a while, people will invest in a second meter just to have a backup kind of thing. That's what I have. I've got my backup one, which is total crap. That's why I don't like it. But if you really want to have 2 good ones, that's not a bad idea either. That's ideal. I'm just cheap, so I decided to buy a nice meter and a cheap meter. But the electrical wiring diagrams, how to read those and all that kind of stuff, service and install manuals are typically going to be with a system if it's newer or even if it's older. Sometimes it just depends on who installed it. Those installation guides, those service guides, that's where you're going to find those troubleshooting charts, those flow charts, all that stuff that does that step-by-step, like the troubleshooting trees and everything like that. That's where that's going to be. It's also going to include in there your control board status codes for the LED flashing, or for an LCD, it's on B4. It's like, oh, what does that mean? And that's what those guides will have in there. They'll have a chapter that'll be marked for that. It is not always ideal with the installation guides as far as how much information they give for service instructions and service work. But you've got it where it's going to have a lot of good information for you. It'll let you know the model number. It'll let you know sometimes it'll have a copy of the wiring diagram that might be clearer because over time the wiring diagram faded that was on the unit. or whatever, but you've got a fresh, crisp new one right there in the installation guide or the, with everything. My big encouragement though is, if the system doesn't have one of these guides, if it doesn't have that packet right there, you can usually look them up online. Just about every major manufacturer has got most, if not all of their, at least all of their newer systems, if not most of even their older systems. They'll have an install guide with instructions and everything like that available online to download. Just a PDF file or something like that. I can't tell you how many times I would download a PDF and be like, oh, okay, now I know how to troubleshoot this. Now I know how to work on this. Especially for thermostats, when they get really complicated and weird and you've got to go into the control settings for it, you've got to verify that, it was installed correctly and is working properly. I had this one lady one time, it was, I have to make sure that thermostat is the issue. Now, the problem with their thermostat was the top left corner of the touchscreen wasn't working to adjust her temperature. I was like, okay, let me see what I got going on. And I knew these thermostats had a setting where you could lock out the temperature change on the system. You could lock it out and make it so that no one can do it unless you have a password or a code or you knew how to punch into the system kind of thing. So I spent probably 30, 45 minutes between online looking up guides and information on how to get into that system for that thermostat, and then troubleshooting it, making sure it's getting voltage, sending signals, all that kind of stuff. I checked all my wires, I checked everything. I mean, very, very thorough, very sure. And I got to the end of it. I was like, yep, your thermostat, that touch section of the screen is just worn out. That's all it is. I called Honeywell. I made sure that thing was having an issue. And that's what you got to do, sometimes. But it's, as you run into situations more and more, you're going to be able to diagnose it faster, because it's going to be less of a guessing game and more of, I've seen this before, let me check this component. Because last time I had this happen, it was this capacitor or this contactor or this wire connection. And now I've got the same problem again on a different system or on a different unit. And let me see if that's the problem again. And that's, sometimes it is, sometimes, nope, that's not it. It must be a different issue, That's typically what you're going to be seeing for most troubleshooting guides and everything. So, all right, I'll get back to troubleshooting when we get back at 2:30, and then we'll finish this up and we'll do some Cengage simulations after that.
You said 2:30?
Yeah, 2:30.
Which one are we going with Cengage now, the heat or the cooling? I'm on the commercial cooling right now.
We're probably going to be doing cooling just because that's a little bit simpler as far as it's electric. And then we'll probably do a couple gas heat just because those are really, really simple. So just to give you guys, a look at.
Hey, Mr. Marsh.
Yes, sir.
Hey, man, I never received my password for that, the Cengage.
Yeah, I still haven't gotten anything. Tim hasn't gotten back to me, or Mr. Holloway hasn't gotten back to me yet about when we're getting those. I think
you might want to ask Wagner, because remember I told you that's how I got mine. He should have one for you.
Yeah, he might already have, because I didn't get an email about him.
Because he said he sent it out. He sent me mine, so you might want to get with him.
Yeah, check with Josh, see if he's got. He might honestly. I know he was talking to Tim about it as well, or Mr. Holloway as well. So.
And I emailed my chapters I was missing for homework. I emailed those last night. I don't know if you got them.
Yeah, I think I saw something this morning when I looked at my email.
I think it was 12 through 17.
Where's that?
Yeah, I'm about to finish mine up now. I got 2 more chapters.
Oh, yeah.
Yeah, I got it. There it is.
Okay, cool.
Yep.
And we're going to be doing chapter 18 now, or that's going to be the next homework, or?
Yeah, that'll be your last homework for this one, and then I've got to finish today. I'll have it up on Canvas for the rest of the week. Well, the final. So
How we know our grade 5 quizzes that we done took already?
for the ones that I haven't uploaded them yet. That's all.
Okay, because we don't know what we missed or what we got wrong, man.
No, I know. I feel bad. I've been really behind on grading with Canvas and everything, just because evening class I got was wonderfully on week 3 had 0 grades punched in. So I've been trying to like focus on that more than any other class. I've been putting you guys to the wayside. I feel bad, but
But yeah, man, I had took a quiz and I think I had put the answer was like something with the number 5 or something like that. So I put the number 5 and I got it wrong because I didn't type out the 5.
yeah. But 2:30 we'll be back here, and
All right.
I'll get us all good for the rest of the slides and everything.
All right.
All right.